To explain the current crisis in cosmology, we first have to understand what Einstein called the biggest blunder of his life. In 1917, Einstein proposes lambda in his general relativity equation because the prevailing belief at the time was that the universe was static, and his original general relativity equations predicted an expanding or collapsing cosmos, which he thought was wrong. But in 1929 Hubble discovered the universe was expanding, and Einstein dropped lambda from his equation, calling it the biggest blunder he ever made in his time. Without lambda, general relativity perfectly described an expanding universe. So later, in 1998, observations of distant supernovae showed the universe's expansion is accelerating, not slowing down as expected. And physicists realized lambda wasn't a mistake at all in Einstein's equations. It represented dark energy, a mysterious repulsive force making up to around 68% of the universe. Lambda cold dark matter, or ΛCDM, became the standard model. But the standard model assumes that dark energy is constant and never changed over time. In the early 2000s, scientists came with the Hubble constant. But in the 2010s, early Hubble Space Telescope measurements of the Hubble constant suggested around 72 km per second per megaparsec. Meanwhile, CMB-based estimates gave lower values, around 65 to 68 km per second per megaparsec. At first the difference wasn't alarming. But then in 2013, the Planck satellite released ultra-precise CMB data, giving the Hubble constant the value of 67.3 plus or minus 1 km per second per megaparsec, firmly lower than Hubble Space Telescope. In 2016, the SHUS team reported H0 equals 73.2 plus or minus 1.7 km per second per megaparsec. A 3 sigma tension with Planck. In scientific contexts, a sigma discrepancy refers to a significant disagreement between a measurement or observation and a theoretical prediction or expected value. Statistically, a 3 sigma discrepancy means there's only around 0.3% chance it's a fluke. This made it officially a tension, with scientists calling it the Hubble tension. In 2018 to 2019, independent methods, gravitational lensing time delays and TRGB stars confirmed the higher Hubble constant values, deepening the crisis. By 2020, the tension reached 4 to 5 sigma, less than 1 in 100,000 odds of being random error. Papers began calling it a crisis in cosmology. Theorists proposed radical fixes: early dark energy, modified gravity, phantom lambda, etc. Now, with recent observations from James Webb Space Telescope, have confirmed it officially in a full-blown crisis. So, the ΛCDM model assumes that dark energy is constant and never changed since the dawn of the universe up to now. But that's not what astronomers have been finding with recent observations made with the James Webb Space Telescope. Astronomers are assuming that dark energy's density might evolve. If confirmed, this would imply lambda isn't constant. This would explain why James Webb Space Telescope found galaxies as massive as the Milky Way existing just 300 to 500 million years after the Big Bang. As ΛCDM predicts smaller, slower growing structures early on. These galaxies are too big, too soon for standard dark matter models. Implying that our cosmological models must change, because cosmologists can't agree on an answer to how fast the universe is expanding. Thanks for watching. give a like, comment, share, and subscribe. Until next time.